Okay, the first problem, what is the mean of the roots of the following quadratic equation? This is really a problem that you need to have gone through algebra to answer. So I'll do a little background. If you have a function where the largest term, largest degree is 2, it is called a quadratic relationship, and a quadratic relationship will have a graph that is a parabola. And a parabola will have its solutions at the x-intercepts. So you can have up to 2 answers. Now I've drawn an orange parabola that has 2 answers, but I could just as easily draw a yellow parabola that has 1 answer, where just at that one point. And I could also draw a parabola that has no solutions or no answers. This one would have imaginary answers. So, roots, the root is another way of saying solution, which is also an x-intercept, where it crosses the x-axis on the graph. So, they are all synonyms. You need to be able to function with all of them. Here we go. In order to solve a quadratic, 2 things must be true. First, it must be equal to 0. And second, it must be in factored form. Remember shipwreck factors? You're about to do it right now. All right, so this is equal to 0, which made it a little bit easier, but it is not in factored form. So to get this in factored form, you're going to have to ask yourself, what times what is 20? But adds together to make -9. So what?
-5 and -.
So we have x minus 5 times x. 4. All right. And I can prove to you that these are equivalent, and you don't have to do this in the competition, but I'm going to do it now anyways. Using this distributive property, what is x times x?
X squared.
That's right, x squared. X times -4 is? Is -4x. What is -5 times x?
-5x.
And what is -5 times -4?
20.
And so you add these together and you get x squared minus 9x plus 20. See, these are equivalent statements. They are the same. Now, before I went on this happy side journey, we now have our quadratic in factored form, and it is equal to 0. Now, we are multiplying 2 numbers together, and we are getting a product of 0. What must be true of one of these 2 numbers?
It's 0.
It's 0. Okay, so I'm going to break it apart, and I'm going to see what's going to make this binomial 0.
X is 0.
Oh, so if x is 0, 0 minus 5 is -5. Not so much.
Oh, it's minus.
So something minus 5 is 0. 5, okay. So x is equal to 5 over here. What's going to make this binomial 0?
4.
4. So our solutions to this are 5 and 4, both positive. What is the mean of 5 and 4? What is in between 5 and 4? Come on. Oh, come on. What is in between 5 and 4? 4.5. And it doesn't specify what form you have to write the answer, so 4.5 is fine, 4.5 is okay. All right, number 2. How many seconds are in a 30-day month? Write your answer in scientific notation. All right, so 30 days. So we have 30 days times 24 hours per day times 60 minutes per hour. Oh, I can already see I have a mistake here, so I'm going to start over again. 30 days times 24 hours a day times 60 minutes in an hour times 60 seconds in a minute. So we have 2, 0.0592000. I like to put the commas in so it's easier to say. That's 2 million seconds. Isn't that kind of crazy that 1 month is 2 million seconds? Well, 2.5 million seconds, really. And so they want you to round your answer. No, sorry, not round your answer. They want you to answer in scientific notation. Now, in scientific notation, you will remember that you have to have 1 and exactly one number to the left of the decimal. And then you can have as many as you want over here, doesn't matter. And that's times 10 to the blank. Well, if the decimal place is here, how many times do we need to slide it over so that it gets here? Let's count. Out loud, as loud as you can. You won't get yelled at, you're in school, but it's Saturday. Here we go. 3, 2, 1. 1, 2, 3, 4, 5, 6. It's almost like I'm here by myself. So that means it's times 10 to the 6th. We have our 2 here, 5, 9, 2. And we don't have that last blank because we don't have, ooh, that is a big eraser for a big mistake. And there we have it. That is the answer. All right, next question. Okay, we have to be able to get these sequence problems. This is nothing more than a basic linear, it's just a basic linear equation. So we have our first term, second term, third term, fourth term. We need to go to the 0 term, and following the pattern, we have not a 0, oh my goodness, we have a 5, because our counting number is 5, which means our slope is, what is our slope? The crickets are chirping. That's right, but I'm here by myself, so who am I expecting to answer me? So, we know my my slope is 5. What is the slope? And we know y is equal to mx plus b. B is the y-intercept. In this case, the y-intercept is?
What?
5.
5.
So we have y is equal to 5x plus 5. And we have the 100th term. So we have 5 times 100 plus 5. So we get 505 is my final answer.
You got that, like, way ahead of you.
I'm glad that you got that way ahead of me. I wish you'd answer me when I spoke. It makes me feel foolish. Maybe I am foolish. Yeah, thank you. I love you too. All right. The mean of 5 numbers is 15. When a 6th number is added, the new mean is 31. Well, that must be a big number. What is the 6th number? Well, in my first sequence, I have 5 numbers, and they have a mean of 15. And so that is a total of 75. So if I took all the numbers and added them together, I'd get 75. In my new sequence, can you answer that, please? Who could be calling on a Saturday?
Mom.
Yeah, could you answer it? I have 6 numbers, and they have an average of 31. And 6 times 31 is 186. So what is the difference between these two? We have 1. We didn't have to borrow. That's 1, 1. So the answer should be, hopefully, 111. And it is. Woohoo! All right. Next question. John has $1,000 in savings account that earns 6% compounded annually. That means at the end of every year, he has 5% added on to his original value. How much money will John have in his account at the end of 3 years? Round your answer to the nearest cent. Wow. There's going to be some discrepancy here, but hopefully not. But here we go. So we go, depending on how you do this. Good morning. So we have 1,000 times 1.05. Why 1.05? Well, the 1 represents the 1,000 that already he invested, and the 0.05 represents the 5% that gets added to his money. And so that equals 1,050. But that's only 1 year. So after a second year, he has another 5% added. So I just multiply that value by the, and that's at the end of year 2. And then one more time for year 3. And so we get $1,157.60, and it says round to the nearest cent, 63 cents. All right, number 7. We're flying through this one now.
We are.
Yeah, we're almost done. We have 4 problems left.
Mr. Potato Head?
That's right. Do you know who Mr. Potato Head is?
Yeah, it's the guy in Toy Story.
Mr. Potato Head was a toy
I know what he is.
that happened to be.
Eyes and
Yeah, and you could put like his hand in his nose. Yeah.
That's probably you did because you're mean.
It's not what I did. It's not my fault that my nose looks like a hand.
It does not.
All right. Mr. Potato Head has 3 choices of eyes, 3 choices of nose, and 2 types of ears, and 4 different mouths. If all the pieces are put in their proper locations, how many Mr. Potato Heads can be made? All right. So really, let's just try something for funsies. 3 times 4 times 3 times 2. That's right, 72. 72 different choices. Because for every 3 choices of eyes, he can have all these different types of configurations. It's a lot. All right, if a fair die is tossed 2 times, not once, but twice, what is the probability that it lands on a prime number both times? All right, so let's go through our prime numbers. Is 1 prime?
Yeah, no.
1 is neither prime nor composite. Is 2 prime?
Yes.
So that's a prime. What is 3 prime?
Yes.
Is 4 prime?
Yes. No.
Is 5 prime?
Yes.
Is 6 prime?
Yes.
You're just saying yes because you know that I say no all the time.
Yeah,
All right,
I'd like to say
so that means in one toss, your probability of getting a prime number is 3/6, which is equal to 1/2. Well, so what is 1/2 for the first roll, 1/2 times for the second roll? Well, your odds of getting 2 primes are 1/4. All right, number 9. The length of a radius of a circle is increased by 50%. By what percent will the area of the circle be increased by? Now, there are 2 ways to do this. One really quick, if you remember your 7th grade math. One is still pretty quick, but I'm going to pick a length. All right, so let's say, just for funsies, that the radius is 2. The radius of a circle is a 2. I'm going to go with 2 because what's 50% of 2? 1.
Oh, that's easy.
Right. Yeah, I'm trying to work with easy answers, very easy numbers. So the game plan here is, yeah, you could do 100. That'd be another one. Small circle divided by big circle will give me my percent increase, right? Oh, sorry, other way around. So, all right. So, if my small circle has a radius of 2, 2 squared is 4. So we have 4 pi for my small circle. Let's just get rid of the picture altogether because I don't think my game plan is sound. All right. My larger circle will have a radius of 3 because 50% of 2 is 1. 1 plus 2 is 3. 3 squared is 9 pi. All right. So the question is, by what percent will the area increase? Well, here we go. If I was at 9, if I was at 4, I'm now at 9, that is a difference of 5 pi. So for percent increase, I'm going to take the difference and I'm going to divide it by the original area. In this case was 4 pi. Pi divided by pi is yummy, but it is 1 in this case. And so we have 4/5. Well, 4/5 is wonderful, except we want a percent. So what is 4/5 as a decimal? 4/5 as a decimal is 1.25. And what is 1.25 as a percent? You just slide the decimal over 2. Chirp, 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 chirp. Come on!
Wait, what's the question again?
What percent is 1.25?
What percent is 120?
And thank you for answering in the form of a question. This is Jeopardy, apparently. This is Jeopardy. All right. If f is a linear function, so let's make a little table. So we have x, and we have f of x, better known as. All right, so we have 0, 3, 5, 18. So right now I know my y-intercept. What's my y-intercept?
3.
3. So we know b is equal to 3. And since it's linear, we have y equals mx plus b. All right, so we need to find the rise, we need to find the run. Is this going to give me the difference here? Is that going to give me the rise or the run? That is an actual serious question I want to answer. It'll give you the rise. Well, how about here? What will that give you?
The run.
That's good because we already used rise and there are only 2 options. All right, so what is the rise here?
What is 15?
What is the run?
What is 5?
What's the slope?
What is 3?
What is 3? So we have y is equal to 3x plus 3. And so now we just need to take our f of 3 and plug it in. So what number do we plug in into this equation? Well, obviously we plug in 3, but does that go in for x or does that go in for y?
Y.
Notice how it goes in for x, because the number that's in the parentheses is your x value. So you have y is equal to 3 times 3 plus 3. So you get 9 plus 3, which is equal to 12. And there we have it. I hope you enjoyed or were entertained by our video. Have a great weekend.